speaker is Lynn Gueissaz from Lausanne, Switzerland. She is a researcher and lecturer with microtraces. The talk she's giving to us today is entitled The Potential of Pyrolysis GCMS for the Analysis of Tire Traces and Tire Treads. Welcome.
Good morning, everyone, and thank you for coming to my presentation. First of all, I would like to thank the National Institute of Justice and also the FBI Laboratory Division to invite me to this symposium. So I will speak about tires. First of all, I would like to present you the context of my research. Tire traces are important in the field of accident scene investigation. When you have multiple collisions, the attribution of the different traces to each vehicle involved is a precious help for the reconstruction of each trajectory and so for the understanding of the accident. More generally, any crime scene where a tire trace is observed and collected, we can make a chemical comparison between the trace and the tires of the suspected vehicle to link the vehicle to the crime scene. So the aim of my research is to link the tire trace to its source with the help of the following two propositions. The recovered trace comes from the suspected tread, or the recovered trace comes from another source. Here you have the plan of my work. First, I optimized the parameters of the analytical method to produce low intravariability on the same tire. Then I applied the method on a limited set of different tires to evaluate the intravariability and the intervariability. Then I applied the method on tire traces, and finally, I increased the number of tires. For the optimization step, I use experimental design because they allow to find the important factors of the analytical methods and their effects on the response surface. They also allow to identify the possible interactions between the factors and interpret correctly the results while optimizing efforts and time. So I would like to find the analytical parameters that give the smallest intravariability for a same sample. For the pyrolysis, I identified two factors that I would like to optimize, temperature and time, and I choose the variability for the response factor, and I use two different tires for doing that. Here you have the first design I performed. So each point of the design represents the analytical conditions for the pyrolysis. And at each point of this design are performed at least 3 analyses per sample. Here are the results. So at 450 degrees, there were a few compounds, and you can see that the intensity is low, and the peak discrimination was difficult. So it was the case at 5 seconds and 40 seconds. So these points of the design were not good. At 600 degrees and 650 degrees and 900 degrees, the peak discrimination was better, the intensity was greater, and the number of compounds were also greater. So these two points were better. And it was the case at 5 seconds and also at 40 seconds, and this leads to the following hypothesis. Temperature has more influence than time on the results. For the study of the variability, I made a visual comparison, and then I integrated all the peaks which were well discriminated, and the total variance and the relative standard deviation were chosen as response factor. Here you have the results for the two samples. You can see that at 650 degrees during 15 seconds, the total variance is the lowest, and the number of RSD up to 5% is 0 in 1, which is really good. And at 900 degrees, for the two samples, you can see that the total variance has increased, and the number of RSD up to 5% are important. So I could reduce the response surface. At 450 degrees and below, the temperature seems not to be sufficient to decompose the samples into volatile products. And at 900 degrees and above, the variability is increasing, and it is typically what we would like to avoid. So I could reduce the response surface. And finally, you can see here a central composite design. It was the last design I performed. So again, each point of the design represents the analytical conditions for the pyrolysis. And finally, I could found a local optimum at 650 degrees during 15 seconds, and these conditions are used further in this study. For the tire traces, we made a collaboration with the Touring Club Suisse, which is #1 in Switzerland in assistance and road rescue. We did some emergency braking on a racetrack to produce tire traces that we have then collected, and we also did some sampling of the tires, threads, and after, back to the laboratory, we analyzed all the samples. Here you have the tires selected for the test. You can see in the first column the different brands, and you can see that we have 2 Goodyear, but in the second column you have the model, and you can see that the Goodyear are different. One Goodyear OptiGrip and one Goodyear Efficient Grip. In the third column you have the size, and all the tires were from the same size. And in the fourth column you have the dot number, which is the number from the Department of Transportation. And this number indicates the date of fabrication. The 2 first numbers are for the week, and the 2 last numbers for the year. For example, the Continental was brought out the 7th week of 2009. Here is the test procedure. So first we cleaned the wood. Yes. Then the vehicle drove during 4 laps to heat up the tires, and then did an emergency braking. When the vehicle stopped, we do the sampling by applying a white gelatin just behind the wheel. And of course, we noticed all the information about the test on each sample. Then we change the tire, and we do the tread sampling by cutting some samples from the tread, and of course, the labeling. Here you have an example of a tire trace collected with the white gelatin and left by this tire. You can see that the general pattern is conserved, and the trace is formed by little rubber residue of about 1 millimeter. And so this rubber residue and the samples from the treads were then analyzed by pyrolysis GCMS to compare the chemical profile. I would like to test the tire tread homogeneity, so for each tire, I took several samples. Here you have the number of samples per tire, and also the number of analyses performed per tire. And for the traces, for each trace, I analyzed 3 particles separately. Then I integrated more than 8 peaks based on retention time and MS spectra. I did some pretreatments, and then I used exploratory statistics. I used principal component analysis because they allow to visualize the data by reducing the dimension of the data, and also allows to find the important variables. And I also use cluster analysis because I would like to see how the different analyses could be grouped without any prior knowledge. And here are the results. So each color represents a different brand. So you can see that all the replicates from the different brands are well grouped together and well separated from the rest. In brown, you have the 2 Goodyear, and you can see that the replicates from the model Efficient Grip are well grouped together, and the replicates from the model OptiGrip are also well grouped together. But you can see that the tires in blue and green show some overlap. But if we are looking at the PC3 versus the PC1, you can see that this time the green and the blue tire are well separated. So this means that some important information is contained in PC3. Here you have the cluster analysis with all the replicates of the 10 tires and also the 3 analyses per traces, and all the traces are grouped in the same cluster as its corresponding tire. So in conclusion, for the 10 tires tested, the replicates from the same tire are grouped randomly in the same cluster. So the samples are homogeneous and the method is repeatable, and the interoperability for each tire is low. All the tires are grouped in different clusters. So the interoperability between the different tires is greater than the interoperability. And for the traces analyzed, the 3 analyses from one trace are grouped in the same cluster. The trace samples are homogeneous and the method is repeatable, and the interoperability for each trace is low. And each trace is grouped in the same cluster as its corresponding tire. So the interoperability trace its tire is lower than the interoperability trace another tire. At the end, I increased the number of tires, so I used 46 tires split in 11 categories. And now it's a little bit complicated. So for the BF Goodrich, I used 4 tires with the same characteristics. That is to say that they were from the same size, same made in, same dot number, everything the same. For the Continental, I used also 4 tires with the same characteristics, but 3 were made in Portugal and 1 was made in Germany. For the Dunlop, I also used 4 tires with the same characteristic, but 2 tires had the dot number 2906 and 2 tires had the dot number 0908. For the Goodyear Excellence, also 4 tires, and you can see the difference. 2 tires with the same characteristics and 2 tires with the same characteristic but with a different size and different dot number. For the Michelin Energy, I used 12 tires with very different characteristics. So they were all Michelin Energy, but with different size, different countries, different dots. I used 2 tires from Michelin Pilot Primacy with the same characteristics, 2 Michelin Primacy HP, 4 tires with the same characteristics, Pirelli Euphoria Run, 4 tires with the same characteristics, 2 tires from Potenza Bridgestone, and 1 was made in Poland and 1 was made in France, and 2 Turanza Bridgestone, 2 tires with the same characteristics, and 4 tires from Turanza from another model with the same characteristic. Here is the results of the PCA on these tires. First, you can see that the 4 tires with the same characteristic from Goodrich, all the replicates are well grouped and well separated from the rest. In green, you have the 2 tires Potenza Bridgestone, and even if the maiden was different, all the replicates are well grouped together. For the Pirelli, the 4 tires with the same characteristic are also well grouped and well separated from the rest. And in violet, you have the Turanza Bridgestone, and you can see that the 4 tires are well grouped, even if the spread is a little more important. Here you have 4 tires Michelin Pilot Primacy and 2 Turanza Bridgestone. All the replicates are also well grouped, but there is some overlap. And here is something interesting. So in green, you have the 2 Dunlop. So the 4 Dunlop are with the same characteristics, but the 2 which have the dot number 2906 are well grouped together, and the 2 with the dot number 0908 are well grouped together. So a separation can be made with the dot number. And this is also the case for the Goodyear, with the 2 with the same dot number are well grouped together and separated from the 2 others with the same dot number. And in red, you have 3 tires from Continental, and the 3 made in Germany are well grouped together, but the one made in Germany is alone and well separated from the rest. If we look at the Michelin, I used 12 tires from different size, different dot number, different countries, made in, and so on. But they are well grouped together. And we also have in yellow 2 other Michelin from another model, and it is overlapped with the Michelin Energy. And if we have a look at the PC3 versus the PC1, this time you can see that the Goodyear are well separated from the Michelin. So in conclusion, pyrolysis GCMS show good potential for the analysis and the discrimination of tire traces and threads. The high power of discrimination is based on brand and model, but also on dot number, on size, and made in. And this leads to more difficult to create a database because it requires a large number of samples and regular updates. For the future, we'll extend the model to more tires and do blind test and application to wheel case. And I would like to make a special thank to the TCS team. And I don't know if any of you have seen the movie Rubber from Quentin Dupieux, but in a nutshell, it's about a murderous crazy tire. And thankfully, to my results, I can now hope to stop his killing rampage. Thank you for your attention.
Thank you, Lynn. And thank you to all our speakers for some great talks. We will entertain some questions. In fact, our schedule says that we can go till 12:15 with questions. I do have a question for Lynn. You took your trace samples from pavement, correct? After bringing the car to an abrupt stop, I guess, leaving. Now, why didn't you just take them off of the tire? What differences would you observe? Just taking neat samples.
I would like to see if the white gelatin could really take the trace. If I took on the tires, I'm sure, okay, it comes from the tire, but how is the trace? And you can see that on the white gelatin, the general pattern is conserved. And I think it is also an important information. So the little rubber residue, we are more sure that they come from the trace, like that.
Okay. I wondered too if there was some pyrolysis going on in that deposition of the tire on the pavement too. Another question I had too was concerning fillers. Did you look at any fillers in tires? Sometimes they add calcium carbonate and limestone.
No, because they are always the same. So I think for a good discrimination, it was better to work on the organic compounds.
For Mr. Bartlett, have you tested any firearms that have been scrubbed clean prior to shooting any of the non-toxin, maybe testing them with redizinate to see if there's any lead, just from perhaps a test fire from the factory prior to shipment, and then continuing with your test with non-tox?
Well, as you may have alluded to, the weapons are actually test fired in the factory before they're shipped, so they already start out with the synoxid residue in them. To clean a gun as clean as you're talking about typically would involve solvents, and those are normally already contaminated from being used already. And what we were trying to do is basically look at what the criminal would be doing to his gun, and if in fact he knew about non-toxin, was trying to hide the fact that there's gunshot residue. That was the case in that I had my intern clean the weapon as much as possible, other than sonicating it or hitting with solvents or hitting it with water. And it truly is, there's so many surfaces on the gun that have residue on it from prior discharges that it really does take a lot of effort to get rid of that residue.
Then also on the bullets, I haven't dissected a non-tox bullet yet. Are they lead-free, or are they just totally metal jacketed?
No, there is a lead core, and almost all the ammunition we got had a full metal jacket where the nose, the sides, and the base were coated with the brass. The first box of 9mm we got were referred to as soft point, and that did have the tip of the bullet exposed, but that would not come in contact with the rifling. So we didn't think that there would be any particles being produced by the bullet being forced down the barrel.
Oh, so then those could have some lead wipe and be positive for redizinate on a target substrate.
Those, yes, those could test positive for lead wipe.
Great, thank you very much.
You're welcome.
Hi there. I had a question for Mr. Floor, and I just was curious in your study in the cases, if you tested other people's gloves and stuff that had the same job description but weren't present at the scene, just to sort of, I know you tested some of the people that were at the scene at different distances, but just, did you do any baseline testing?
No, we didn't get any gloves or materials from other people in either case. That would be a good thing to do because we were cognizant of the fact we'd actually asked, had that individual in the first case being prepared to go into Iraq, had they been on a makeshift range in Kuwait practicing with grenades? I mean, let's spin yourself up to use your material that you might use in country. So we asked that question, the answer was no. They had done shooting, but they hadn't thrown grenades. And in the second situation, the same question was asked. Had this person has a normal routine course of their work, be required to go out to a range and, if you will, qualify with a grenade or at least practice, and then qualify with a handgun and throw grenades? And the answer there was no.
For our purposes, if we ever had a domestic incident, it wouldn't be an issue.
Right.
Any more questions? I had one for Louisa. I was curious. You said you didn't find a way to differentiate the passenger from a driver of a vehicle from the residues. I have read there's like differences in those bags, but has that been a trend away from differences in the bags on each side?
You've asked a really good question, actually, because part of my remit when I started the work was to try and identify whether there was a disconcerting difference between the passenger and the airbag itself. And the literature states that they actually explode by slightly different techniques, so I assumed that the particles that were formed would be slightly different. But actually what I found was there's so much overlap from the dust that's produced, it's never going to be possible really to say one particular particle came from maybe the passenger or the driver's side itself. So that did surprise me. And consequently, if you've obviously got one airbag that's gone off, perhaps if the driver goes off but the passenger doesn't, although you have a distance issue, so obviously the passenger will be slightly further away, you could never put somebody directly in the driver's seat just because this dust actually flies around the vehicle.
And if I can add to that, with the testing that we did with particle analysis, there is a distinct difference between the particles that are produced in the driver's side airbag as opposed to the passenger side. But with the bags venting in the compartment of the vehicle, you end up with the residue on basically everyone that's in there. To try and point a finger at a specific individual, I think the only way you could do that would be with the any kind of scorch marks, that type of damage to the clothing that was specific to the one airbag or the other.
I know why the people in the back stayed back there, so they could get to the lunch quicker, I guess. I hear that lunch is down in the exhibitor area. There's boxed lunches down there for us, and I think this comes with your program. You don't have to pay for this, so that's a perk today and tomorrow. So with that, I would say that's the conclusion of this panel. Thank you for coming.